graph of f can be given, and you have to draw the graph of f prime. And graph of f prime is given, then we have to draw f. Okay. Okay. So let's see both the cases. So let's say the graph is, we have graph of f. It is like this. Okay. And from this graph, we have to draw the graph of f prime. Now, drawing f prime is easy. When graph of f is given and we have to draw the graph of f prime, that's easier than drawing the graph of f from f prime. See, when you have to draw the graph of f prime, that means the derivative. That means, derivative means what? Derivative means the slope of the tangent at each point. That is the geometrical meaning of slope. Of derivative. Slope of tangent at each point of f. So that's what we will do. Now we have, we should be very good with the concept of slope. So if we look at this graph, first of all, you should identify the points of minima and maxima, because we know that at minima and maxima, f prime will be 0. So you can see that at this point, this looks like a maxima. So here, and obviously if you draw a tangent at this point, it will be a horizontal line. And slope of a horizontal line is 0. Same thing here. Here, if you draw a tangent, it will be a horizontal line. This is the point of minima. And that's why slope of tangent line will be 0. So you know one thing, that at this point and at this point, the graph of f prime will touch the x-axis. It will touch the x-axis because f prime will be 0 at these 2 points. Okay. Then if you look at this point, here the graph is very steep. Very steep. It starts from being very steep and it is increasing. So here, derivative or the slope of tangent will be positive. You know that wherever the graph is increasing, f prime derivative is greater than 0, right? So from this point to this point, the graph is increasing. So here it will be positive, but it will be more positive here because here it is more steep. And then it is becoming less steep. So very big positive number, then small positive number, and then it keeps becoming smaller and smaller and smaller, and then it becomes 0, right? And then after 0, it has started decreasing, right? And so if the function is decreasing, then we know that its derivative is less than 0, right? And here the graph is less steep, very less steep. So the slope of the tangent will be negative, but very less negative, like minus 0.0001, right? Very close to 0, but a negative number. And then it starts becoming more and more steep and steep and steep. Maximum steepness, not maximum steepness, but here it will be the most negative. This is the point of inflection. It will be the most negative here. And then again, it will start becoming, the negativity will start decreasing. So least negative, then more negative, then more negative, then more negative, then maximum negative will be at this point, at the point of inflection. And then the negativity will start decreasing, and it will be least negative here. Here, if you again see, it is very less steep. Then it will become 0. Then again, after this point, it has started increasing. So we know that here it will be positive, but very less positive. Then more positive, more positive, more positive, more positive. And at the top,
Sorry, 1 second. My mom is asking me to open the door. I'll go open it for her.
Oh, okay. Sorry. No problem. No problem.
Okay, I'm back. Sorry.
Okay, no problem.
Yeah, I was just writing it down.
Okay, so this is what you have to identify if you have to draw the graph of f prime when f of x is given. Okay, just identify the nature of slope at each point. And now once you've done this, then you know that starting from this point, this graph will be, I mean, the y value of f prime will be a very big positive number. And since this graph goes to infinity, we will also have a very big infinite, like very big number coming from somewhere here. It will be very big positive number. So wherever this point is, let's say here is some point. So at this point, it's a very big positive number. So the graph will come from here. Okay. And then
Uh-huh.
the numbers, you see the positivity decreases. I mean, like it's a very big number, let's say 1000. And then it starts decreasing from 1000 to 900, 800, 700. It starts decreasing like this. And then eventually it will touch zero at this point. It will touch the x-axis. And then after this point, it should be,
Sorry.
oh,
Uh-huh.
then after zero, it's negative. So
Uh-huh.
negative, 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 negative. And then this point, the most negative. And then after this point, still it's negative, but the negative numbers start to increase. So increase, 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 still negative. This point, it becomes zero. Then after this point, they are positive.
Uh-huh.
So the graph will look like this. It starts from here, very big positive number, but then the numbers start decreasing, 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 decreasing
Uh-huh.
till this point. At this point, we know that f prime will be zero, so it will cross the x-axis. And then the slope is negative, so it will go below x-axis. Negative numbers increasing, increasing. I
Mm-hmm.
mean, absolute value of negative numbers will be more, more, more. Then at this point, this is inflection, point of inflection. So it will be most negative here. And
Okay.
then after this point, it's still negative. I mean, it's still,
Uh-huh.
f is still decreasing, but the negative numbers, negativity starts decreasing. So it will start coming up, up, up. Then at this point, it will become zero. So it will cross the x-axis and then it will be positive.
Okay.
So it will be kind of like this. This is the graph of f prime, yellow one.
Got it.
And if you want to verify if your answer is correct, you can do
Mm-hmm.
that. So if you see the green graph looks like a cubic function,
Yes.
right? It is touching the x-axis at 3 points. And we know that graph of a cubic function is like this.
Uh-huh.
This increasing cubic function, and this is decreasing. And we know that derivative of a cubic function, so if you have x cubed, its derivative, we know that it's 3x squared,
Okay.
which is quadratic. So the yellow graph that we have got, that looks like a parabola, which is quadratic,
Mm-hmm.
right? So that means this is correct graph. This is the correct graph for f prime.
Okay.
Okay, but don't rely completely on this technique because sometimes like the function can be any weird function.
Uh-huh.
Okay, so if you have to draw the graph of f prime, if graph of f is given, then this is the only way. You identify the nature of slope at all the points and then just draw the rough sketch.
Okay.
Okay, now we'll have a graph of f prime
Mm-hmm.
and we'll try to sketch the graph of f from that.
Okay.
Okay, and we have kind of a same graph for um, f prime, so I'll copy this.
Okay.
Okay, this time this green curve is the graph of f prime,
Uh-huh.
and from this we will try to sketch the graph of f. Okay. Okay, so when graph of f prime is given and you have to draw this graph of f, first identify the points of minima, the points of maxima,
Uh-huh.
and the points of inflection.
Okay.
Okay, so we know that points of minima and maxima are those points where the derivative is equal to zero, right? And
Mm-hmm.
since this is the graph of f prime, so it is zero wherever it is crossing the x-axis.
Okay.
This point, this point, and this point, right? These are the
Mm-hmm.
points of minima or maxima. We
Okay.
don't know which point is minima or maxima now, but these are all the critical points.
Mm-hmm.
Now, how will you identify which point is exactly minima, which point is maxima?
By either doing a sign analysis, but if the function
Yes.
isn't given, then
You can still do the sign analysis if the
uh-huh.
graph is given, because you can see that below this point, this is all negative because it's below the x-axis, right?
Yes.
So if f prime is changing its sign from negative to positive,
Mm-hmm.
then
It means there's a minimum.
that means it's the point of minima. So this point is a point of minima. Then it is changing its sign. So in this interval, from this point to this point, it is positive.
Mm-hmm.
So now at this point, it is changing its sign from positive to negative. So this is a point of maxima.
Okay.
So this is a point of maxima. Then it is negative, 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 negative. And after this point, it again becomes positive. So this point is again minima.
Okay.
Okay, so first identify the points of minima and maxima, then identify if there are any points of inflection.
So it changes concavity.
Mhm.
Got it.
And you also know that the points of inflection are those points where f double prime, double derivative is equal to 0. At these points, you will have points of inflection. Okay.
Okay.
So you can clearly see that we have at this point, the slope will be 0,
Uh-huh.
derivative will be 0, slope of the tangent will be 0. So this is the one point of inflection. And then at this point, the tangent line will be horizontal.
Uh-huh.
So this is again an inflection point.
Got it.
Okay. So now that information is what you need to draw the graph of f of x.
Okay.
But there is one catch when you are drawing the graph of f.
Uh-huh.
So do you agree that this is a cubic function, right? It looks like a cubic function.
Mm-hmm.
So if we have a function f of x as 3x squared, just 3x squared. So what will be its derivative?
6x.
6x. Okay. What if you have a function like this, 3x squared minus 2?
Mm-hmm.
What will be its derivative?
Also 6x.
Also 6x. And if we have something like this, derivative will be
The same.
also 6x, right? So the thing with this case is, if this is the graph of f prime x, then f of x could be infinite functions. That's why we do a plus c.
Yes.
So these are all c's, values of c plus
Uh-huh.
c, right? So
Yes.
whenever you have to sketch the graph of f, then one thing is that there will not be one correct answer. There will be multiple, like infinite f. Right here, you can see there can be infinite functions whose derivative is the same thing, right? Its derivative is also 6x, its derivative is also 6x. All of them have derivative same. So for one graph of f prime,
Mm-hmm.
you have infinite f, right? The only difference will be that it will be shifted, like it will be translated vertically, right? If you're doing minus 2 plus 100, what will it do? It will translate the graph, like this thing will translate the graph down by 2 units, and this thing will translate the graph up by 1,000 units.
Uh-huh.
That will be the only difference, right? So the graph that right now we are about to sketch, that will be just one of the infinite graphs. Okay. Okay. So now we will sketch the graph. Now, since we know that this red point, it's a point of minima. So here we can draw the minima. Now, when it's a point of minima,
Mm-hmm.
it will be like this, kind of like this. Now, it's not necessary that it should be here. You can draw it here as well. You can draw
Okay.
it here. You can draw it here. We don't know its position because of plus c. We don't know what will be the value of c. Okay, you can draw it anywhere.
Okay.
But we know that since it's the point of minima, so it will look like this. right? The graph will be falling and it will take its minimum value at this point. Then at the point of maxima, you can draw it like this, maximum value. F will take its maximum value at this point. Then again, it will start falling. Here it's point of inflection. And then here again, we have a minimum. So it could be like this.
Okay.
Okay, so now we can draw it. Now, again, this is, again, it's going to be a rough sketch. We know that here it's point of inflection, so here concavity will change. So I'm going to draw it now. This is point of minima. So this looks like concave up. And then after this point, it changes its concavity. It becomes concave down. It's concave down, down, down. Okay. And then at this point, it changes again, it changes its concavity. Concave down. Then at this point somewhere, it will become concave up. And I have done a terrible job.
No, I understand. I'm like that too.
Okay. And okay, one more thing. It's not going to pass through this point. It will just change its concavity. So wait, it's going like this. Now at this point, it's somewhere here, its concavity will change. It's not necessary that it has to touch this point. No, only you have to change the concavity.
Okay.
Somewhere here, yes. Again, change it. Okay, that's still better. So this is one possible graph for F, the yellow one.
Mm-hmm.
And if you shift it up or down, okay, then you'll get different values of F for the given graph of F prime.
Okay.
Okay. So now let's do an FRQ
Okay.
based on different scenarios, like a lot of things can happen.